Welcome back, teachers and educators. My name is Hilary Romer. I'm a Saskatchewan teacher who has been helping create resources with the Saskatchewan Mining Association's Education Outreach Program. In our last video, we explored recovering dissolved potash and how do we know it's KCl. Check out the SMA website under Outreach for the many free resources, lesson plans, and curriculum connections. In today's video, learners will be challenged to build their own model to replicate solution mining and see firsthand how solution mining works. This lesson is called Solution Mining Model and is part of our Solution Mining series. It is a good idea to familiarize yourself with the step-by-step instructions on our website so you're better able to assist your learners through this challenge. I suggest if your students have not already done so, you may want to first do the introductory lessons, Potash, what is it, and is there potash under my feet? Also, you may wish to have your students check out the GeoExplore website to learn more about the story of Saskatchewan potash. GeoExplore is an amazing interactive tool to explore the geological features of Saskatchewan that combines information, pictures, and an interactive map. To build the models, you will need to decide if learners are working in groups with their own models, or if you will create one class demonstration model. It is important to note that none of the materials for this lesson are provided in the potash kit. However, as you will see, the materials are inexpensive and easy to find. Now is a good time to plan your worksheets and materials. For materials, you will need clear plastic cups, 1 per model, plasticine, various colors to represent the different rock layers, coarse salt or kosher salt to represent the potash layers, straws that will act as the drill and drill casing, clear flexible tubing. You can buy this aquarium tubing from a pet store. These represent the pipelines from the wells to the mill or ponds. Syringes, these need to be the proper size for the tubing. The syringes will be used to represent the pumps that inject warm brine and extract the solution of dissolved potash from the prairie evaporate unit. Blue food coloring, you will use this to dye the fresh water to allow students to view the dissolution process. And finally, you will need wooden skewers with points cut off. These are helpful to clean the excess plasticine out of the straws when drilling. To engage learners, explain that they are geologists hired by the largest potash solution mine in the world, located at Belle Plaine, Saskatchewan. Their task is to mine potash. However, their challenge is that the potash layer they are targeting is too deep to mine safely using conventional underground mining techniques. So they must find another way to get the potash to the surface. They must design a plan with explanations and drawings for approval, and then execute their plan by creating a model. Before groups begin examining the materials and designing their plans, you can guide learners to help you set up the preparation for the models, or you can set up the preparation for the models yourself beforehand. Model preparation. Prepare cups with a layer of plasticine at the base, a middle layer of coarse salt, and a top layer of more plasticine. You may want to prepare some smaller pieces of plasticine ahead of time so it is a little easier for students. Make sure each plasticine layer has a good seal with the cup so that the water or air does not move up or down the sides of the cup or in between layers. Once learners sketch out their plan with explanations and drawings and receive approval from you, they can begin building and testing their model. Learners should add to their design plan if they decide to alter anything with an explanation of why. If you're doing one classroom model with more guided lessons, tell learners that you will pick the best design plan to demonstrate with. That group of learners' design would win the challenge. Proposed winning model design. Use the straws to drill through the rock to reach the top of the layer of the potash. You will need to drill 2 holes evenly spaced apart. The straws can be cleaned using the wooden skewers to remove excess plasticine. You will know when you have reached a potash layer when you see salt crystals in the plasticine. You do not drill through the salt layer, just into it. Remove the straws and insert the tubing into both drill holes. Use extra plasticine to make a seal tight around the tubes. Half fill a plastic cup with warm water, then add a few drops of blue food coloring. Insert the syringe into the water and fill it with the water. Attach the syringe to one of the tubes and slowly inject the warm colored water into the salt layer until you start seeing the water come up the second tube. Then take the syringe off and place the tube end into the cup of the water. The water fills any void space around the salt. Look at the side where the warm water was injected. You should see a dissolution cavity forming. Connect the syringe on the other tube and draw water out of the salt layer. The water has the dissolved potash salts within it. Remove the syringe and save the salt water solution into an empty cup. This will become their reservoir cup that they will observe over several days. Learners may want to label their models so they don't get confused which cup is which. While you are drawing water out of the potash layer, fresh water is being drawn in. Leave the syringe attached to the outflow tube. After learners build and test their models, you can have them remove 2 syringes of water daily. Learners would place it in their reservoir cup for 4 days while writing down their observations. They could be given some time at the start of class or at the end of class to do this. If you decide that learners will continue to pump out 2 syringes of salty water each day and record their observations may include the cavity in the salt layer increasing in size, salt crystals forming at the bottom of the reservoir cup, along with salt growing up the sides. This is the KCl and NaCl salts. The fresh water cup should remain clear. Some reservoir cups might even develop salt crystals on both the inside and outside of the cup as the days progress. Some summary questions or class observation questions include: how did you remove the potash from your model? How does your model represent solution mining? What do you observe happening to your model or reservoir after several days of mining potash? In this video, we explored the Solution Mining Model Challenge. We discussed the materials, preparation, and the proposed winning model design. Until next time, on behalf of the Saskatchewan Mining Association, thanks for watching. Remember, always stay curious, ask questions, and most importantly, never stop exploring. Bye.